It is given that the real and imaginary parts of a complex number x plus iy are related by the differential equation given. By solving the differential equation, given that y is root 3 and x is 1, shows that the relationship between the modulus r and the argument theta of the complex number is this expression. So definitely we need to solve this differential equation, and then we will understand how a complex number arises here at all and how to relate r and theta. So how to solve this differential equation? We can see that dy dx is equal to what? We move this to the right and it becomes y minus x and over x plus y, and we can see each term contains x or y, and we can understand that dy over dx it's a function of y over x. What do I mean? If we divide by x, it becomes y over x minus 1 and 1 plus y over x, and it can be solved by the substitution y is vx. It is called homogeneous differential equation. And how to understand that we should use this method? In general, there are three options by separating variables, but definitely here we cannot split it into two parts with everything with y to the left and everything with x to the right, with y to the left, with x to the right. The second option, it's by integrating factor, but it must be of a certain form. This form is given in a data booklet, and definitely it's not that equation. And the last third option, it's when derivative is of y over x, and we solve it by the substitution. How to understand or how to see it when each term, when we don't distinguish x and y, each term is of the same power of x or y. It may be like squared, 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 squared. So we understand that if we divide by x, or for some problems it may be when we divide by x squared, we get such expression. So the derivative is of the form or is a function of y over x. So we need dy dx, and dy over dx is v is a function of x, and hence we apply an implicit differentiation, and we can see that it's a product, so we apply also a product rule, so it becomes derivative of v, so it's dv over dx times just x plus v derivative of x with respect to x is just 1, so it's just the product rule. So dy dx is dv, this expression. And now we can substitute and get the next. So dy dx is dv over dx times x plus v is y over x. It's v minus 1 and 1 plus v, or v plus 1. And hence we get an equation, differential equation, in terms of x and v only. And how to solve this obtained equation? And we can see that if we move this v to the right, we can separate variables and solve by separating variables. So it becomes dv over dx and multiplied by x is equal to v minus 1 over v plus 1 minus v. Let's make a common denominator, so it becomes v plus 1, v minus 1 minus v times v plus 1, so it becomes v minus 1 minus v squared minus v over v plus 1. So dv over dx and x is equal to, we can factor out minus, and it becomes v squared plus 1 over v plus 1. and we move just as proportion or cross multiplication or something like that, or multiply both sides by v plus 1 and divide by v squared plus 1 and divide by x, so it becomes v plus 1 dv over v squared plus 1 and minus dx over x. Minus may be here or maybe on the left hand side, it doesn't matter. And then we integrate both sides. The right hand side is just ln, it's easy, but what about the left hand side? We can split it into two parts, so it becomes integral v dv, v squared plus 1 plus integral dv over v squared plus 1 is minus integral dx over x. It's arctangent, it's just data booklet, formula is given, and how to integrate this. It's typical situation by substitution, and we can consider u to be v squared plus 1, hence du dv is 2v, and hence integral v dv v squared plus 1 becomes integral v dv, it's du over 2v and just u, and we can see we cancels and it becomes integral du over 2u. Or if you can notice that derivative of v squared is just v, so we can move this under this differential, so you can notice that it's d of, and we can see v squared plus 1, it's d of v squared plus 1, and when we differentiate it, it's you just derivative, it becomes 2v, and derivative of 1 is 0, 2v, but there is only v, so 2v arises, so we should compensate this 2, so it becomes like this, d of v squared plus 1 over 2 v squared plus 1, and actually this v squared plus 1, it's our substitution u, it's called the inverse chain rule. If you can notice this, you may write directly the answer or use substitution, usual substitution, u as usual. So finally, this integral is equal to what? du over u, it's ln u, so it's half ln of the absolute value. You notice that in general integral 1 over x, it's ln of the absolute value, plus it's arctangent of v and is equal to minus ln of the absolute value of x, and somewhere must be plus constant. There must be constant. And what is u? U, it's v squared plus 1, and definitely it's positive, it doesn't matter what v is, it's always positive, so absolute value is not necessary, so it's a half ln of v squared plus 1, and what is v? V, it's y over x, so it becomes y squared over x squared plus 1 plus arctangent of y over x is minus ln of the absolute value of x plus constant. Then we need constant. Actually we can solve for y and then find constant, or we can find constant now. Let's find constant now, and it is given that y is root 3 when x is 1, so 0.1 root 3 is given. So substituting root 3 for y and 1 for x, we get the next half ln of what, 3 plus 1 plus arctangent of y over x, it's root 3, is minus ln of 1 plus c. What is arctangent of root 3? It's the angle for which tangent is root 3. Tangent is what? Sine over cosine. Sine to be root 3, it's what? It's 60 degrees, so it's pi over 3. It's pi over 3. And a half ln of 4, it's 0, it's c. And ln of 4, it's 2 squared, and using property of ln we can move it in front, so we can write that it's just c, it's just ln of 2 plus pi over 3. Hence it becomes a half, and we can multiply each term by 2 to simplify it, so it becomes ln y squared. And we can do common denominator here, x squared plus y squared over x squared plus 2 arctan y over x is minus 2 ln of the absolute value of x, and we can move this y here to the power, and it becomes minus ln of x squared. And if it's squared, we can not write the absolute value, and plus c, and c is plus ln 2 plus pi over 3 by, but also it's also will be multiplied by 2, so it becomes 2 ln 2, and again it's can be written as ln of 4 plus 2 pi over 3. And we can move this ln to the left, and it becomes ln of y squared plus x squared over x squared plus ln of x squared. And we know property formula is given in the data booklet. The sum of two ln's is equal to 1 ln over product, and you can see that it becomes times x squared, and hence it becomes just ln of y squared plus x squared, and plus 2 arctangent y over x, and is equal to ln of 4 plus 2 pi over 3. And actually we don't need to solve it for y, because question is what? About a complex number, and now we should understand how to relate it to complex number. And we should recall what is actually modulus and argument of a complex number. Complex number, here it's x plus iy, and it can be represented on the organ diagram, where it's a real part, it's imaginary part, and it's actually a point with coordinates x and y. And notice that it is given that our complex number is x is 1, y is root 3, so it's the first quadrant. And anyway, we understand that modulus of a complex number r, it's a distance from the origin, and it is equal to x squared plus y squared. And what is argument? 0 angle is here, and in anti-clockwise positive angles, in clockwise negative angles, and it's actually angle theta. And it's very important that since this complex number is in the first quadrant, we can say that theta, or which is argument of this complex number, is just arctangent, because we can see tangent is root 3 over 1, which is y over x, so theta is arctangent y over x, and it's true only for the first quadrant. It's also true for the fourth quadrant, and there will be arctangent of y over x, but y will be negative, but arctangent of negative value is minus arctangent of positive, so it will be correct. But if it's the third or the second or the third quadrant, theta is pi plus arctangent y over x. And for the second quadrant, it will be arctangent of negative, so it becomes pi minus some acute angle, so it becomes angle between 90 and 180 degrees, so it's correct. And for this quadrant, arctangent yx are positive, so you get pi plus arctangent y over x, so it's correct, but it's actually not necessary here. So since it's the first quadrant, theta is arctangent y over x. And hence we can see that our equation becomes y ln of this, it's just ln of r squared plus 2 arctangent y over x, it's theta, is equal to ln of 4 plus 2 pi over 3. And we need to solve for r, actually. We should solve for r and get this expression. And how to do that? We can move this 2 in front and divide each term by 2 again. So it becomes ln of r plus theta, and we can move theta to the right. So it becomes minus theta and plus a half ln of 4 plus pi over 3, and again it's 4 2 squared, and squared moves in front, and 2 over 2 it's 1. So it becomes ln r is minus theta plus ln of 2 plus pi over 3. And just undo ln, just by definition log 2 8 is 3, why? Because 2 cubed is 8. So ln is log to the base e, so it becomes e to the power of this is equal to r. So r is e to the power minus theta plus ln 2 plus pi over 3. And it's like 2 to the power of 5 plus 3, it's 2 to the power of 5 times 2 to the power of 3, so we can rewrite it as e to the power of ln 2 times e to the power of pi over 3 minus theta, and e to the power ln 2 is just 2, the property of ln, it's a to the power log ab, it's just b. So it becomes r is 2 e to the power of pi over 3 minus theta. Let's check. 2e to the power pi over 3 minus theta. And that's all for this question.